All right, friends. So last week we looked at solving multiplication problems using an area model, which required us to find partial products for our one big product. Today we're going to be looking a little bit more at partial products. However, we're going to be taking out a giant step. So we're not drawing area models. We're simply using our partial product strategy in order to find the one big product for our multiplication sentence. Okay. So really quickly, I want to review what an area model looks like. But of course, first we need a multiplication sentence to build our model from. So I want to look at 12 times 24. Okay. I'm going to use this 2-digit by 2-digit multiplication sentence in order to build my area model and solve using my partial product strategy. All right. So first I want to build my area model, which means I need to set up a box. All right. And I think I'm going to put 12 down the left side. So let's go ahead and cut that off like that. And I'm going to put 24 at the top. All right. And to keep my numbers nice and neat, I'm not going to write them out today. I'm going to go ahead and type them so you guys can see clearly. All right. So I know I have 12 going down on the left side. So that's a 1 right there. And that area, of course, is bigger than this area because it's worth 10 because my 1 is in my tens place. And then I have a 2 in my ones place. All right. And same with 24. This area is larger than this area because this area is worth 20 and this area is worth the 4. So I'm going to go ahead and label that side as well. All right, so we have our 12 and our 24. Now, we know that we need to make sure all of our players on team A speak to all of our players on team B. And what I mean by that is we need to multiply the 1 by the 2 and by the 4. We also need to multiply this 2 by the 2 and by the 4. All right, now remember, it's very important that you hold on to place value. So this 1, again, it's not worth a 1. It's worth a 10 because it's in my tens place. This 2, not worth a 2. It's worth 20 because it's in my tens place. All right, so let's look in this big box first and let's write the multiplication sentence and solve. If this 1 is worth a 10 and this 2 is worth a 20, then I have 10 times 20, which is going to give me 200. So 10 times 20 equals 200. And I have my first partial product. It's only a piece of my larger product. All right. And then I have this 2 down here and this 2 up here. But remember, again, this 2 is worth 20 because it's in my tens place. So I have 2 times 20, and that's going to give us a 40. All right, so let's put that in that box. All right, I have this 1 and this 4. This 1 rests in the tens place, so it's worth 10. So I have 10 times 4, my next multiplication sentence. And that's going to give us our next partial product of a 40. And then lastly, I have this 4 and this 2, which are worth 4 and 2 because they both sit in the ones place in each of their numbers. So 2 times 4 is going to give us 8. All right. So we have all of our partial products. We know that after we get all of our partial products, the only thing left to do is to add all of them together because they're parts of a whole, they're partial products to get our one big product. So let's go ahead and add all 4 of our partial products so that we find one final product for the multiplication sentence, 12 times 24. So let's move this so we can see all of our partial products. We have 200 plus 40 plus 40 plus 8, and that gives us a grand product, a final product of 288. I have 200, 240, 280, 288. All right, so my final product for 12 times 24 is 288. All right. And we solved that using the area model and seeing those partial products. Today, we're going to eliminate the step of using the area model because you guys are dynamic at knowing which numbers need to speak to which numbers. We just need to make sure all players on team A speak to all players on team B. Okay? So I want you to remember something called FOIL, right? It stands for something. So we're going to look at first, outside, inside, last. And we're going to be looking at our numbers. So that means I want to look at my tens. So my tens times my tens. And then my outside, my tens times my ones. Inside, my ones times my tens. And last, my ones times my ones. That way I know all players speak to each other. Okay? So we're going to FOIL this multiplication sentence. First, I have my tens times my tens because they're both first in their numbers. Those are the first digits. So I have 10 times 20. That's going to give us 200. All right. And then next I have outside. Outside I have a tens and I have ones. So I'm going to do 10 times 4. That's going to give me 40. All right. And I want us to line these up according to place value. So try to put your numbers right up under one another. All right. And then I have first outside, inside. Inside, we have 2 and 2. Now, this 2, of course, is worth of 20, and this 2 is worth of 2. So we have 2 times 20. That gives us another 40. All right, again, we're going to line these numbers up so they're easier to add. And then we have last. That means we're looking at our ones, the last digit in both of those numbers. All right, we have 2 times 4, and that gives us an 8. All right, so now we have the same partial products without drawing out this huge area model, right? All right, so I want us to go ahead and add it all together. So we're going to add these all together, right? And I'm adding this side. Okay. If I look in my ones column, let's move this friend so we can see. If I look in my ones column, I have a total of 8. So I'm just going to add 8. And we're doing the standard algorithm for addition. All right, if I look in my tens column, I have another 8. If I look in my hundreds column, I have 2. Right? Therefore, my answer is 288. I added all those partial products to get one final product. And guess what? We got 288 over here as well. So you can see that you can eliminate this entire step of drawing an area model by just using your partial products. All right? And that's how you use your partial product strategy to solve a multiplication sentence.